All right, greetings, good people. Today we're going to look at some integration techniques for rational functions. I don't got a lot of time, so let's go ahead and get right to it. So here you can say the function we're trying to integrate is 5 over x squared plus 8x plus 19. This particular function, when you have a constant over a quadratic or a constant over something of a quadratic form, like it could be something like x to the 6 plus 7x cubed plus 9, anything that's of a quadratic form. This is a key guide for a technique called completing the square. So I'm going to complete the square just like you did in some of your elementary algebra classes. So I'm going to complete the square on my denominator. And so what's going to happen is this will become x squared plus 8x plus 16 minus 16 plus 19 dx, and thus that'll become these guys here can be factored as x plus 4 squared, and this guy plus 3 dx. And so that's in the form of arctan, and so therefore now I can write my answer as 5 over the square root of 3, 5 over the square root of 3 arctan x plus 4 over the square root of 3 plus c. So what we're going to do, we're going to make our numerators progressively bigger in power and see how that affects the solution. So here we did a constant over a quadratic, and we did this completing the square deal and got this arctan rule. So next, let's make our numerator linear and see how that changes things. So I'm going to keep my denominator the same and just going to give it a linear numerator. And so let's say my numerator now, it's say x plus 7. So it's x plus 7 over x squared plus 8x plus 19 dx. Now, this variety, since the degree of your denominator is 1 power more than the numerator, this is a good candidate for U substitution if everything works out well. So we're going to do a U substitution, and we're going to make U equal our denominator, which is x squared plus 8x plus 19, which means du would be 2x plus 8. And now if you look here, of course you're trying to make this stuff match, and U matches that beautifully, but this doesn't really match x plus 7. So we're going to do a little algebra to try to make it match. So let's say we divide by 2, and therefore 1/2 du would be x plus 4, and I'm sorry, du here was 2x plus 8 dx, and so 1/2 du is x plus 4 dx. Now we're getting pretty close. So we got an x plus 4 dx, and this is an x plus 7 dx, but we can easily reconcile that issue because we can think of x plus 7 as x plus 4 plus 3. So we can think of x plus 7 in this manner, and really we can split this up into two integrals, one where it's x plus 4 over x squared plus 8x plus 19, and the other where it's 3 over x squared plus 8x plus 19. So if we do that, so if we split them up, so say I have the integral of x plus 4 over x squared plus 8x plus 19 dx, and then plus 3, the integral of 3 over said denominator. Sorry, run out a little space there. Now I can use this U substitution on this guy. So let's look at the U substitution. We can already find this answer pretty easily if we just think about what we did on the first example. So here, let's look at the U substitution. So x plus 4 dx is 1/2 du And u is our denominator. So that's 1/2 du over u. And this guy, if you just recall what we did in the previous example, what was the square root of 3? So this is 3 over the square root of 3 arctan x plus 4 over the square root of 3 plus some constant. And of course, 1/2 du is 1/2 ln u. Well, what's u? U is x squared plus 8x plus 19. And then, of course, that's plus 3 over the square root of 3 arctan x plus 4 over the square root of 3 plus some constant. All right, so I got a little more jazzy, just making it linear instead of just a constant. And it required us to do two things, actually, a u sub and still to the arctan, completing the square. Okay, let's do some more. So next, I'm actually going to make my numerator of power 3. So let's see. So we're going to integrate, and we got x squared plus 8x plus 19. And so let me think this numerator through just a little bit. So we'll go x cubed, and we'll say 10x squared, and we'll say minus 4x plus 5. All right. So I hope this works out okay. I really don't want it to get too messy. That's why I try to think a little bit about the numbers I was selecting. But I think it's going to be fine. So what if we get something of this variety? Now, things that may come to mind would be maybe U substitution. But when you do U substitution, you always want to make U, if it's stuff that's polynomial, the guy of the higher power. But du must be in the numerator, not the denominator. So this would, if I was thinking U substitution, I would make u this, which would put du down there, which can't really happen. So we can think of just about simplifying this expression algebraically through just division. So let's try to do long divisions here and see what we get if we get something that's a little easier integrated. So I'm going to divide. So we have x squared. My divisor is x squared plus 8x plus 19. And my dividend is x cubed plus 10x squared minus 4x plus 5. So x will go into x cubed x times, and that will give me x cubed 8x squared 19x. And then when I subtract, I'll get 2x squared minus 23x, and I'll bring down the plus 5. And then x squared will go into 2x squared 2 times. So that's times 2. And that will be 2x squared, and then 16x, and then 38. And then we subtract. And that'll give us negative 39x minus 33. Oops, excuse me, minus 33. Now this is actually my remainder. This is lower than this. So there's, it's not any more division I can do. And so the answer would be x plus 2 plus, well, let me say minus 39x plus 33 over x squared plus 8x plus 19. And so now this is the guy we can integrate. And if you look at it, this is a very basic integral here. And this is taking us back to what we did in the last problem where we had the U substitution, but the numbers aren't the easiest numbers in the world to deal with, but we think we can still deal with them. We think there is a way. So let's write this new integral in this form, and then let's see how the attack goes. So what we're going to end up integrating. So now we're integrating x plus 2 minus 39x plus 33 over our regular denominator, x squared plus 8x plus 19. All right, let's do this junk. And so we'll think of it as two integrals, and we'll go ahead and already just integrate this one. And this will be x squared over 2 plus 2x. All right, so now let's play around with this one. So there's a minus sign here. And so let's do a little U sub. So let's say U equals x squared plus 8x plus 19, which means du equals 2x plus 8 dx, which means, so let me think of a way to do this. Let me think of, so I got various ways of doing this that are going through my brain. And let me think of the way that I think would be probably best. So I think what I'm going to go ahead and do is I think I'm going to multiply this by 19.5. So let's say 19.5 du is going to be 39x plus, we'll see, 8 times 20 is 160, but I'm going to take off 4, so it'll be 156. All right, so 19.5 du is 39x plus 156 dx. All right, I think I have a little bit, I'm in pretty good shape. So again, 19.5 du would be 39x plus 156 dx. But this is 39x plus 33. No big deal. What we can do, and I'll write it under, well, let me write it here. So I'm going to continue this process on the blank, on another sheet. But here, let me write that this is going to be 39x plus 156 minus 156 plus 33. So notice I didn't add anything to this problem. I added 0, but doing it like this allows this guy to match this guy. And so what I'll do is I'll break this up into two integrals, one where it's 39x plus 156, and the other where it's negative 123 over our denominator. All right, so we'll have two numerators, two different integrals, both over x squared plus 8x plus 19. The first guy will be 39x plus 156 over that, and the second guy will be negative 123 over that. The negative 123, of course, is going to act as the arctan, completing the square guy, and this part, of course, is going to satisfy our U sub. So let's go ahead and do our U sub. Remember, we still have this part, and also remember the all-important negative sign that's in front of all of this that's going to go on. But let me deal with this. So let me concentrate on what this is going to equal for right now, and I'll come back to this. So, and I'm not going to forget about that negative sign, that minus sign there. So, and let me just have this here as I can look at it as I'm writing. So I'm integrating 39x plus 33 over x squared plus 8x plus 19. And what I do is I have this U substitution where 19.5 du is 39x plus 56. And what I did to this guy is I split it to 39x plus 156 minus 123. So for the 39x plus 156 part, that's going to be 19.5 du, excuse me, 19.5 du over u. And now for the 1 minus 123 minus, that's going to be 123 over the square root of 3 arctan. I can already take that integral arctan of x plus 4 over the square root of 3 plus c. So I can already take that one. I guess I could have already took this one as well, because this is simply going to be 19.5 ln, and u, of course, is x squared plus 8x plus 19. And then we have the minus this 123 over the square root of 3 arctan x plus 4 square root of 3 plus some constant. Excuse me. And so now let's bring the whole thing in. So really in front of that was the x squared over 2 plus 2x. And again, the all important minus sign. So let's put it all together for the final answer. So it would be x squared over 2 plus 2x minus 19.5 ln x squared plus 8x plus 19 plus 123 over the square root of 3 arctan. Let me write that right here. Plus 123 over the square root of 3 arctan x plus 4 over the square root of 3 plus some constant. So there it is there. So we took you through some 3 progressions, I think it was, of integrating rational functions where the numerator and denominator are polynomials. The numerator was a the denominator was a quadratic, and we played with the numerator a little bit, making, at first it was a constant, then it was linear, and then this last guy, it was cubic. And you can see how our answers change each case. Each case of answers got a little more complicated and required a little more action. But in all, it was a beautiful process, and we will see you next time.
Specialized in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section. Vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.